Good morning everyone. I am Deepak Kumar. I am working as assistant professor in Government Engineering College Munger in Computer Science and Engineering Department. Today I am going to take session on network topology. So after the completion of this session, you will be able to identify the different types of computer network structure, that is the topology. What is the structure of different networks, how these are connected. And next you will be able to describe the pros and cons of each structure or each topology, and means how one is beneficial, other is unbeneficial in each situation. So we'll start with the basics, like prerequisites. To understand this session, basically you require a basic knowledge of computers or fundamentals of computers. So I have included some basics here also, like you should know what is internet. So everyone uses internet all the time. So can anyone tell me what is internet? Actually, what is internet is? Anyone? What is internet? What do you think is internet? Anyone?
Internet connects people from all over the world.
Yes, it connects people. It helps to connect, and basically, internet is a network of networks. So by definition, interconnection of networks. So it is internet. So how it arises? First of all, initially in 1967, Advanced Research Project Agency (ARPA), that was a Department of Defense in US, they created a simple network in which two or more computers were connected to a specialized computer, that is called IMP, Interface Message Protocol, and they formed a network. And in 1969, two different University of Stanford and University of California, they connected with each other, and they first sent a message. So that was starting the internet first of all. And later on, in 1970s, the protocol TCP, Transmission Control Protocol, and IP, Internet Protocol, was introduced so that uniformly all over the world, the same protocol can be used so that they can communicate. Because if you are talking in English and you are talking in some other language like French or something, so you can't communicate. There should be one standard that I can say and you can also communicate in that. So as you know, internet communication is essential. So we required a standard. So standard was set by TCP and IP that we follow, and OSI is the organization which uses these standards and monitor this. So we can classify internet based on connections also, or sizes. So if you talk about sizes, if two computers are connected with each other, two or more, they form a network. So when two or more computers are connected and the area within 1 meter, so they can be classified as personal area network. Similarly, when the area increases, so let's talk about we connect the computer within this room, or we connect this computer within this building or within this campus. So they forms local area network within the campus. And if you increase the size across the city, it becomes metropolitan area network. Across the country or continent, it becomes a wide area network. And finally, the internet, that is across the planet. There is one single internet. So if you are connected with that particular network, so you are a part of internet. So you can access all the resources that is available in the internet. So that is basics of internet. So in your mind, there will be question like how the different computers are being connected with each other, or what is the different structure, or how they are connected with each other. So to understand that, you look at two things, basic things like what are the different types of connections that are possible. So one is point-to-point connection, that is dedicated connection. So two computers or two nodes, when they are directly connected with each other with a dedicated link, that is not shared with anyone. So that is known as point-to-point connection. But if they are sharing, two or more computers are sharing as a link, that means whatever data is sending, what is the bandwidth that's available, this bandwidth is shared between various devices, and the available bandwidth will be reduced. So that particular we can call it multi-point. Suppose I am sending 100 Mbps bandwidth and that is dedicated to you. That means all the 100 Mbps you are getting, you can access the internet with that speed. But 100 persons are there and they are using it at the same time. So that bandwidth will be divided into 100%. So it will be reduced. So hence it will become a multi-point. So point-to-point is dedicated, multi-point is shared. Next, the topic that we are going for discussing, that is topology. What is basically topology means? So basically, topology is a geometric representation of the relationship of all the links and the linking devices. Links means devices that are being connected with a particular link. So how they are being geometrically represented. So that things becomes the topology. So you can also say that topology refers to the way in which a network is laid out physically. So two or more devices, when they are connected with the links, and these devices are known as nodes. So basically there are 4 different topologies that we use for connection: mesh, star, bus and ring. Each topology has its own advantage and disadvantage. So I'll discuss with the first one, that is mesh topology. In mesh topology, each nodes, that is computers or computing nodes, are connected with every other computing node which is a dedicated link. That means suppose I have 3 nodes. So each node will be connected with each other node which is a dedicated link. So how many nodes will be there? In case there are 2 computers, only 1 link. But if there are 3 computers, how many links will be there? 3 computers are there. They have to be connected in such a way that all computers are connected with all other computers. 6. So if there are 3 computers, are there, so it will be connected with these 2. Similarly, it will be connected with these 2. Similarly, connected with these 2. So total there will be 6. So in case it is half duplex. Half duplex in the sense that bidirectional is possible, that but at a time only one side communication will be possible. But in case it will be represented by a full duplex communication system. Full duplex means both side communication are possible with a single link. So that means if it is n number of connection nodes are there, if it is half duplex, then n into n minus 1 nodes are required. 3 into 2, 6. In case it is full duplex, because single link is able to transfer in bidirectional direction. So n into n minus 1 by 2. Clear? So for this there are 5 computers. So how many links will be there? If it is half duplex, 5 into 4, 20. And in case full duplex, 2, that is 10. And for to accommodate that many links, every device must have n minus 1 IO ports, input output ports. Just like this computer, if it is connected, this particular has 5 computers, then it must have how many ports? It should be connected with every other computers, right? So how many ports it should have? I have to connect this computer to every other computer in mesh topology. So this computer should have how many ports? At least 4. In case it is 5 computers, so 4. Similarly, it should have 4, 4, 4, 4, 4. So 5 into 4, 20 ports is required. Similarly, advantage and disadvantage. Can you think some advantage of this mesh topology? Since every computer is connected with every other computer, it is very reliable. Okay, so it is robust. If one link fails, so from other link we can reach there. It is reliable. But it is having privacy, point-to-point matrix, fault identification, fault isolation easy. Because if wire is not working, we can easily identify communication between them is not possible. We can remove it. Fault identification easy. And what's the disadvantage here? Disadvantage is number of links are very large. Suppose I want to connect 100 computers. In a lab, there are 100 computers. If I have to connect, so number of links will be 100 into 99, which is 9,900. Or in case it's full duplex, divided by 2, 4,950 links. So see how much different links are required. Too much wires. So that is not practically always possible. It is always used in application is in military areas where high availability of computers is required. Then we use mesh topology. The other topology is star topology. The star topology, what happens? We have a central node, normally acts as hub, where all the computers are being connected. And this computer wants to connect with this, it will send a message to this hub, and the hub will redirect to this station. Just like in wireless network. You see there is a router. All your devices, mobile devices, computers, you connect to the router. And the router, whenever you send a message, what happens? The station sends the message from this station you want to send to this. It will go to the first router and then move to station. So wireless network uses star network, star topology. Okay. So what do you think? What is the advantage of star with respect to mesh? Number of wires will become less. If there is 5 computers here, in this case, there will be 5 wires. hub or server, right? So you can only less number of words. What is one advantage there? Advantage is less expensive than mesh, easy to install, robust. If one link fails, other will not be affected. And similarly, easily fault identification. But what is the disadvantage? All the computers are being connected to the central server for communication. But what happens if the central server fails? Everything will be disrupted. No internet, because the network server is failed, right? So that is the main disadvantage. So the disadvantage is single point of failure. If the server fails, everything disrupts. Okay, so this is the main disadvantage of star topology. Next is bus topology. Bus topology, previous to topology, uses point to point, but it uses multi-point. In this, you are shading a common line. It acts as a backbone. That means this is a backbone in which all the computers are being connected with a tab. Okay, and drop plans are given. So these computers are connected to this drop line. Normally when you are going to this lab, you can see all the computers on both sides are placed, and in between there is a single backbone line that is going on, and every computer is connected with this backbone. And whenever the communication happens, suppose it has to communicate this, it will send through this backbone. Similarly, if you have to send this, it will send through this backbone. So it acts as a backbone for transferring of the messages. Okay, so this happens. Now what happens here, like if two computers are being connected and they are very far apart, at that time there can be, on passing the signals, there can be signals may be lost due to heat that is being generated and the resistance that is faced. So when two computers are very large apart, at that time communication may not be proper and it may disrupt. So the length of the particular communication will be reduced. So it is used for a small communication, like in labs we can use bus topology. Okay. So advantage is easy to install, less cabling, and disadvantage, signal reflection at the depth can cause degradation in quality. Last one is ring topology, where every device is connected with every two devices on its left and right. Okay, what is the advantage here? It requires less cabling than mesh, and disadvantage is if one of the cable breaks, complete, it is a ring. If this breaks, complete communication between them will break. So the IBM has introduced this, and to overcome this, dual ring was created. Okay, and if you join two or more topology, like here, this is bus, and you connect to the hub, that becomes star. Combination of bus and star. It is a combination of star, and it is bus, it is ring, it is star. So it becomes hybrid. That may use this normally. So summary is, today we learned that topology refers to which way in which networks are being connected. There are basic four topologies: mesh, star, bus, and ring, and each topology has its own advantage and disadvantage. And if you have understand my session, can you reply what is the solution of this question? If you need to connect 10 computers, total 10 computers are there, how many ports you require if you use mesh topology? For each computer is connected to 10, means 9 ports. Total 10 into 9 is 90. Very good. Next is star topology. If you are using star, 10 computers are connected with the central server. How many wires? How many links? How many ports are required for connecting this link? 10. Each computer will have 10. Nice. Bus topology, again, single line is there, you are connecting with that. How many ports are required? 10 computers, 10 ports. In ring topology, each will be connected with 2, left and right. So how many ports will be required? 20. Okay, so that's it. And next home assignment is identify that in your college which topology is being used for internet. Okay, so this is a home assignment. Thank you very much. Any queries?